Hi everyone, let's make an introduction to domain-driven design. After this introduction, in the next lecture, I will start implementing the domain logic of the first microservice, which is order service. Domain-driven design is an approach to software development that centers the development on programming a domain model. It is especially useful to build systems that have a complex business domain. The main idea is to separate the business model from the infrastructure. If you have already watched the Introduction to Hexagonal Architecture lesson, you should have caught the similarity. Both hexagonal architecture and domain-driven design put the domain logic in center of the software and makes it independent of the outside world. Separating domain logic and infrastructure makes the software easier to design, develop, test, build, and maintain over time. It will keep the domain logic stable and help you to change the infrastructure components and adapt to new technologies easily. There are two sides of domain-driven design: strategic and tactical. Strategic domain-driven design focuses on boundaries in a domain model and introduces the bounded context idea. Domain itself is the operational area of a system, for example, a food ordering application, and it should have well-defined boundaries within that domain. These boundaries are defined using the bounded context, and it will help to group the functionalities of a system. A domain can have one or more subdomains depending on the domain logic. The next important concept that strategic domain-driven design brings is the ubiquitous language. It basically defines a common language between domain experts and developers, so that the system can be designed, developed, and evolved with a well-communicated environment with the contribution of domain experts and developers. The tactical domain-driven design, on the other hand, focuses on the implementation details of the domain logic. Let's start with entities. Entities are the core domain objects. They have the critical business logic. An entity must have a unique identifier that is assigned to an entity when it is created, and it remains unchanged throughout the lifespan of the entity. Two entities with the same identifier considered to be the same object, even if all other properties are different. Likewise, two entities considered to be different if their identifiers are different, even if all of the other properties are same. Entity objects are mutable objects, as it will run some business logic and update the properties based on the calculations. However, it shouldn't mean you should create setter methods for every property of an entity. It should have state-changing methods with well-defined names by using the correct verbs. The second concept is aggregates, which is a group of entity objects that are logically related. For example, you may have an order process aggregate that includes order, order item, and product entities. The important thing with an aggregate is that it should be retrieved and stored as a whole in a consistent state. This requirement brings us to the next concept: aggregate root. An aggregate root is responsible to keep the aggregate in a consistent state all the time. So an aggregate is owned by an aggregate root, and the identifier of the root also identifies the aggregate. Aggregate root is responsible to enforce business invariants. One important thing to help keeping the aggregate in a consistent state is that aggregate can only be referenced through the aggregate root from outside. So all the state-altering operations should go through the root entity, even if the state change is related with one of the other entities. The entities other than the aggregate roots cannot be referenced by outside objects. So when you have completed all state change operations for an aggregate, before saving the data, you should enforce strict validations each time to keep the aggregate in consistent state. Also, applying data store constraints and having an optimistic locking will prevent data loss or corrupted data in case of conflicting updates occurred by multiple threads. To decide which entity will be the aggregate root, you should consider if the entity will be modified independently and be accessed by the identifier from the outside, say from other aggregates. In that case, that entity should be chosen as the root of the aggregate. The next concept I would like to mention is the value object. Value objects are used to bring context to the value. For example, to keep a price of an order, you may think that having a big decimal field is enough. Or to keep an identifier of an entity, you may think having a UID field is good. However, this big decimal or UID field tells nothing about the domain when you first look at them inside an object. When you as a developer or domain expert looks at a domain object, it should be obvious to tell which field is used for what purpose. So if you create a value object with a class named money and keep an inner field big decimal, you can simply use this money value object for the price field. Or for the UID field, if you create an order ID value object and keep a UID field inside, you can use it for the identifier of the order domain object. By doing that, you will get multiple benefits. First, as mentioned, you bring context to the value. Second, you can have business operations in the value object with methods if necessary. And third, you can validate the value of the object while creating the value object in the constructor. One important feature of value object is that it is immutable. That means when you create it once, you cannot change its value. If you want to change the value, you should simply create a new value object with the updated value. Thanks to this immutability, value objects are interchangeable. That means you can use two different value objects with the same value for the same purpose. Alright, the next concept is domain events. Domain events are excellent tools to decouple the domains that are in different bounded contexts. As in every system that relies on events, domain events will lead to an eventual consistent system. So when you run some business logic on a domain through the aggregate route, after saving your changes, you can fire some events to notify the other contexts. In the same way, if you want to run a business logic based on an event on another domain, you can create domain event listeners and subscribe to the events of that domain. The important thing while distributing and consuming events is to have a system with a retry operation. For this purpose, a message queue or an event log will be a great match. In the implementation of domain events, I will use Kafka as the event log store, and it will also allow to see the history of events for the new subscribers. This is called event sourcing, where you keep the state of a system as an ordered log of events. However, note that I will not use the event source as the sole persistence model of the system. It will only be used to keep the events produced by domain event publishers, and later these events will be consumed by the domain event listeners to run the required business logic. Now we are going one level up in the domain-driven design. The next concept is domain service. A domain service coordinates the business logic that spans multiple aggregates. Also, we can put business logic methods into business service if the method does not fit logically into any entity. Domain service can also communicate with other domain services if necessary. Note that domain service is still in the core of the domain logic, so it cannot be reached from outside. And to communicate with outside from the domain logic, we are coming to the application services. These are the services that exposes the required domain methods to the outside. So you should have an interface with methods that the outside objects require and expose that interface. Then you need to implement this application service and accept the requests. Application service should be the place to create and manage transactions, to enforce security requirements, and to load and save the domain state to and from the data store using repositories. So you will need to have the data to run some business logic, but neither domain service nor entities will load this data or save the data after changing it. It is the application service's responsibility to get the data and pass into the domain service or entities. One important thing is that application service should not have any business logic. It is the responsibility of domain service and entities. Regarding domain events, a domain event listener can be thought of as a special kind of application service. The only difference is that domain event listeners are not triggered by an end user, but by the domain events. So the domain event listener will be the first contact point when the domain event is received, and it will organize and call the related domain service for that event handling, which internally will organize and call the entities to run the business logic. Finally, I would like to suggest the two great books about domain-driven design. The one by Eric Evans and by Van Vernon. Here you see some quotes that I gathered from the Eric Evans book. Great, after getting familiar with domain-driven concepts, now it is time to write the domain logic of the order service, which is the first microservice in the food ordering application. Let's start implementing that in the next lecture.